Okay, Pythagorean theorem. So, Pythagorean theorem, named after a guy named Pythagoras, okay? But he came up with this theorem. He realized that all right triangles, okay, have this relationship. So, Pythagorean theorem is here. A squared plus b squared equals c squared. Now, the biggest thing you have to worry about is this c. So the c is what we call the hypotenuse. Okay? So the c is the biggest side. You can find the c by a couple things. You can find the 90-degree triangle and go opposite. And that's my hypotenuse. That's the c value. And that's always going to be the biggest side. So we can use this formula, a squared plus b squared equals c squared, to find any of the missing side lengths of a right triangle. Okay? So let's take a look and see how we can use this to find our missing side lengths. Okay? So again, when we have a right triangle, and again, this only works with right triangles, okay? Find that c value first. So here's my 90, opposite. So this is my c. A and b doesn't necessarily matter. You can switch them, it's still okay. All right? So we have our formula here. So a squared plus b squared equals c squared. So a and b are 16 and x. Doesn't matter which one. Okay? So we'll put a, b. So 16 squared plus, in this case, x squared equals 22 squared. So you'll need a calculator so you can square these numbers. They get kind of big sometimes. So 16 squared gives me 256. Just bring down our x squared. 22 squared, 484. Now, I'm just solving for x now. So how do I solve for x? Subtract 256. So 484 minus 256, that gives me 228. What's the opposite of squaring? How do I undo a square? Nope. Square roots. Okay? So square and square root cancel each other out. So we're going to square root both sides. So this square and square root cancel. It leaves me with just an x. And if I square root .228, I get 15.09966688. So I'm going to say 15.1. So x side length is 15.1, give or take a hundredths of a sec for like 15.1. Yep. So that's the hardest one, finding a side length, a leg. Because if we have both legs, again, we just plug this in our calculator, a and b squared, and then square root the last number we get. Okay. So solving for it, that's why we're doing two of those. So this is the hardest part. So again, find a, b, and c. Again, here's my c. If I want to label this x, I can. So now I have x squared plus 30 squared equals 45 squared. Now, some of you like to save steps, right? Well, what's my step to solve here? Subtract, right? So I can say minus 30 squared that leaves me with x squared equals, so that's what I'm typing in my calculator, 45 squared minus 30 squared, and I get 1125. Okay, so does that make sense? So if you like to save steps, you want to write everything out. Okay, so here we simplified the square, then subtracted. Okay, this process holds the same if I have a B and a C or an A and a C. Okay, so if you have numbers on both sides and you want to start subtracting them over, that's fine. Last step still the same, square root. So square root. So this square and square root cancel. 33.5. 33.5. And again, most of these are going to get rounded because again, there's only a few select. So in the first 100 numbers, there's only 10. Okay, perfect squares. Or perfect square roots. Okay. So a lot of these numbers end up getting rounded. Okay. So on the back, whole application here. So we have a 15-foot castle wall. So this wall height here, 15 feet, surrounded by an 8-foot moat. So our moat comes out here 8 feet, and they want to know how big of a ladder to get to the top, okay, from the other side of the moat. So where's my 90-degree angle at? Yeah, here where hopefully the castle's built 90 degrees straight up, right? That wall. So my 90 degrees here is at the castle wall, so 15 and 8. So again, this is the easy one. A and B, doesn't matter which one. So 8 squared plus 15 squared equals C squared, and here's my C. So I can just plug that left side into my calculator here. So 8 squared plus 15 squared, 289. What's my last step then? Square root. So square root of 289, 17. So minimum length ladder would have to be 17 feet. Basically go from the edge of the moat to the top of that wall. Alright, so another types of problems we may have. Okay. Well, here we have an isosceles triangle whose legs are 10 centimeters and base is 16 centimeters. Now, what do I know about an isosceles triangle? Two equal sides. So I have a triangle, looks similar to this. Isosceles meaning these two sides are equal. Okay? So they want to know the area. Well, to find the area of a triangle, it's 1/2 base times the height. Okay? So legs are 10, so these are 10, 10, and the base is 16. So this full length across is 16. So we have a base, 16, but we don't know the height. Okay? Because when I measure something, how do I measure it? Straight up, right? I don't measure it at the angle. I need to go straight up. And basically we're just going straight up at 90 degrees from that base. Okay? So now I need to calculate what this height is going to be here. Here's my height. So if I go straight up, isosceles triangle, that means this 16 is 8 and 8. Okay, so I have a triangle here, 8, 10, and my height. Does that make sense? Questions on that? So according to this triangle, here's my 90, opposite here, this is my C value. So we have height squared plus 8 squared equals 10 squared. So again, we can subtract that 10 squared minus 8 squared. $36. So subtracting 8 squared on both sides. So h equals 36. I'm sorry, h squared equals 36. And when we square root that, what's the square root of 36? 6. So the height here is 6. So then I can find my area, saying 1/2 base of the original triangle 16. Height is 6. So half of 16 is 8. 8 times 6 is 48. So it's 48 and centimeters squared is my area. So area of that triangle is 48 centimeters squared. All right, so skip that. Skip this second one, the perimeter question. Take a look down at the bottom. Here's the last part of information with Pythagorean theorem. Now, they also realized that we have 3 types of triangles, right? We have a right triangle, which is what the Pythagorean theorem is. A squared plus b squared equals c squared, right? We have an obtuse triangle, and we have an acute triangle, okay? So if I do this Pythagorean theorem, okay, again, if c squared is equal to a squared plus b squared, it's a right triangle, okay? The formula works, it's right triangle. If c squared is bigger than a squared plus b squared, it's going to be an obtuse triangle. And if c squared is smaller than a squared plus b squared, then it's going to be an acute triangle. Okay? So when I look at this, how do I know what a, b, and c is? How do I know what a, b, and c is? C is always the biggest side. Okay? So when we plug these in this case 12 is my C. A and B again doesn't matter. So when I plug this in, 11 squared plus 10 squared equals 12 squared. So this is 121, 100, 144. So when I look at this, it's 221. So what's bigger? A and B is bigger, right? C is smaller, so this is going to be an acute triangle. Okay? So my C squared is smaller, so it's acute. Okay, that's kind of what I would look at. C squared smaller, less than 90 is acute, right? In part B, what's my C? 30. So I have 6 squared plus 16 squared and 30 squared. Well, 30 squared is 900. And 6 squared plus 16 gives me 292. So here, my C is bigger, right? So bigger than 90 is going to be what? Obtuse. So that's an obtuse triangle. And then when we look at the last one here, so again, C is my biggest, so it's 80. So then 48 squared plus 64 squared and 80 squared. So 48 squared plus 64 squared, 6,400. 80 squared is 6,400. Since they're equal, now I have a right triangle. Okay. So there's this relationship to determine if the triangle is obtuse, right, or acute.